Hi. So, we will continue our discussion on overview of computing and evolution of cloud computing. So, where we end in the last talk is where we are talking about the distributed systems, right. So, I believe that we are in this particular slide or in this slide why we require this distributed system. So, as we were discussing, so the nature of the application is one of the driving force, performance is another major driving force, like why the some of the applications, some of the requirements are computing intensive, or some of the things can be data intensive. So, this requires distributed computing. So, another aspect is the robustness, right, like as we are discussing that there should not be any single point of failure. My application does not want any single point of failure. That means, always it should be on, even at a low performance rate I cannot say it should be a failure. In case of a centralized systems, if the system fails, everything drops down, but in this case we still work on the things. Other nodes can execute the same task executed on the failed node. So, that means, I evolved as a system that if it is a failed, the task which is working on the failed node can be executed or shared the load by the other nodes. So, this type of technology algorithms are possible to develop or are being used in case of a distributed systems. So, there are several distributed applications. So, application that consist of set of processes that are distributed across network of machines and work together as an ensemble to solve a common problem. In other sense, I have several applications which coordinate among themselves to address a particular problem. So, this is as if it is a group of people working to address a particular problem. This is primarily useful for a large scale application development or large scale operational need, right, where you have different operation being served by different, and we realize a particular overall job at the end, right. So, there are not only computing aspects, there are several other aspects into the things, as those who have worked or those who are read other things. There is a need of orchestration of these processes, orchestration of these services, like who will do, etc. So, we have to form there. So, there are different aspects, but that is one of the major application of this type of distributed computing. And not only in the past, now also it is mostly several application are clients server type of things, resource management centralized at the server. So, we want to make it in a distributed fashion. There are peer to peer computing, which represents a movement towards truly distributed applications, right. So, there are other type of motivating forces or motivations towards the distributed system. So, this is typically clients invoke individual servers, we are used to that, like client invoke a particular server. So, invocation and results, the server can as a client for another server, right, and there can be there. So, I can say that all those things works in a individually maybe client server mode, but they are basically trying to realize a overall particular job. So, I can have a typical distributed application based on PR processes. So, there are different PRs, there are different applications which are running in the PRs, and it can so happen that these applications talk to each other to realize a particular job, right. So, there are applications based on these PR processes. So, these are different type of distributed computing paradigm. Another computing paradigm which became popular, rather still it is very much popular, is the grid computing, right. There are again different definition of grid computing, and if we look at some of them. So, a form of networking, unlike conventional networks that focus on communication among devices, grid computing harnesses unused resource cycle of all computers in the network and solve problems intensive for standalone systems. So, that means, I have a network of system merged stronger coupled solved some particular problems. So, if you look at other type of decision, grid computing enables virtualization of distributed computing and data resources such as processing, network bandwidth, storage capacity to create a single system image, granting user and application seamless access to the vast IT applications. This is another important way of looking at it. That means, I have a distributed computing paradigm and then I want to realize or virtualize another system over the things, right, which is one of the prime mover of this cloud computing paradigm. Right. I have a several systems over the network, they have different processes, etc. Then I want to have a system evolved out of the things, like or popularly I can say that it is a I want to have one or more virtual machines with defined resources based on my requirement, right. This is one way of looking at it. So, these are the different aspects, and then grid computing is a computing infrastructure that provides dependable, consistent, pervasive, inexpensive access to computing capability. In other sense, I have a resources which are available over the network. And one popular things what we have in our day to day life is, or hear about the things or experience the thing, is the electrical grid, right. So, one good analogy is the electrical grid. So, electrical grids are running and we tap power, we in the sense that organizations or households or the power distribution systems tap power from the grid. So, it is something available. So, in case of we can have a computing analogies, like users or client applications gain access to the computing resources, processors, storage, data applications and so on as needed with little or more no knowledge of where those resources are located. That means, it is a way of looking, I have resources, I tap those resources and I use it for my thing. Say I want to run something on a computing grid. So, I am more bothered about my own algorithm, methodology, and what I think that what is the resource requirement. Now, if that particular computing grid allows me, so I need to hook into the grid and run the resources, run my program or run my processes, and it returns some the resources. So, the grid links together computing resources like PC, workstation, etc., and provides the mechanisms needed to access him. So, if I have a grid, so what I require from the user point of view, a mechanism to access this grid. So, if you look at grid computing characteristics, so say are more than information, it is not only information, it is something data, computing power, so and so. Efficient use of resources at many organization or institute. So, I can have a efficient use of resources, like if you look at our typical computing lab of UG, PG classes, they do except the lab classes, they are mostly underutilized. So, I could have form a computing grid during the off office hours, especially off academic hours, so that other researchers could have used as a computing platform. So, my PCs set of 100 PCs, everything is fine. I virtualize with a layer of another middleware, so that people can work, and as a end user I do not care that what is going at the other end, so long my program, my processes runs faithfully with a particular performance level which is desired by me. So, this is a good chance of using underutilized resources. There is a joint local communities. So, I can have different type of communities, like I can say some grid resources for some biological sciences, some earth sciences, some genetic research. So, there are not only computing, but they also give some basic processes to do that, right. So, those things are available. So, in other sense, I want those resources without having to purchase, install, maintain at my end. Interaction with underneath layers must be transparent and seamless to the user. So, that means, I have a interface as a end user, I should not be bothered about what is going on at the other end of the things, like how you are using the other leverage resources, etc. You may ask me for money, like you may ask that you need to pay so much amount for so much utilization, that is fine, but I may not be willing to, I do not want to go to the nitty gritty of how you maintain your resources, how you maintain your network, what is the services, etc. That is your thing. So, need of grid computing is well known. So, especially scientific research community is a big user of the things, especially data analysis, data analytics, visualization, collaboration between the scientific world. These days across continent people collaborate. Computer simulation and modeling are other common use. Scientific and engineering problems are becoming more complex and need more accurate, precise solution for their problem. Data visualization is becoming an important aspect of the thing. Exploiting underutilized resources may be one of the motivating forces, right. I have a lot of resources which are underutilized, I want to do that. Again, this is another stepping stone for towards your cloud computing. So, who uses grid? There are, as we say that finally, there can physics application, weather application, material science, reactor application and so forth. Very few of them are there, but you can see that all paradigm or of research or all paradigm of different scientific activities are there where who may be needing grid. So, there are different type of grids, we will not go to much nitty-gritty. There is one may be the computational grid, more on the computing, one may be the data grid which serves as a more of a data storage, one may be collaborative grid with that means so that it helps in doing collaborative projects. There are other grids like network grids, so providing fault tolerant high performance communication services over the things. There can be utility grid, in this is the utility form of grid in which not only data and computational cycles are shared, but software or just about any resources are shared of the things. So, I say this is a utility grid. So, there can be different players into the thing. Definitely grid is the central thing, that is the which provides the thing. There are users who uses grid, there are groups which has a group activity, there are different sites or what we say resource availability locations of different heterogeneous sites, etc. Not only that, there are issues of policy maintaining and other things like which can be shared, which cannot be shared, which can be computed where, etc. things are there. Then another important aspect for computing which is pretty popular is the cluster computing. So, what is a cluster? A cluster is a type of parallel or distributed computing platform which consists of collection of interconnected standalone computers working together in a single integrated computing resources, right. So, it realizes. So, key components are standalone computers, maybe PC, workstation or SMPs, operating system, high performance interconnects, middleware, parallel programming environment and applications. So, there are different aspects, these are different components of the cluster computing. So, clusters are usually deployed to improve speed or reliability over that provided by a single computer, right. Typical clusters are like having the properties of the network, faster, closer connection than a typical LAN, low latency of communication protocol, loosely coupled than our SMPs. So, there are several type of clusters, right. Few of them are high availability or failover clusters, like it say the resources should be highly available. If there is any failure of the cluster node, the other things takes care, etc. There are things are load balancing cluster, like if I have particular processes, so the load balancing is done by the cluster. There are parallel distributed processing clusters, right. These helps or this facilitates parallel and distributed processing. So, these are the clusters which are there. So, if we look at typical cluster nodes, so there is several cluster node. So, and a interconnect of network which connect the clusters, and there are different network characterization of the things, like how it will be connected, what will be the different type of mechanisms on the things. So, there are several operational benefit. One is the system availability is one of the thing, fault tolerance is one of the thing, scalability another aspects, OS and application reliability what we expect from the cluster, and high performance. Usually cluster what we try to use it as a high, it will provide us high performance, right. Then there is a, with all this paradigm, we started with the distributed computing and different offshoots like grid, cluster and so forth. We this has motivated to a system or to a realization of a things what we say utility computing, right. What is utility computing or what is utility? Utility typically means that if I have something, I need something, I should be able to get it as and when I require it, right. It is as if you go to the market and purchase the thing or get the services, like I want to book a railway or flight ticket. So, I require some interface, it may be a interface calling a broker or a travel agent, right. So, what I do, I do not care about how things happens, I want a utility to be there. I want even a plumbing job in my home, call up in my residential complex the utility office, and then I say this is the thing, right. I do not care, or I even that the person who is taking the call may not be knowing that how to any plumbing job, but he connects or he or she connects to the particular things. But as a user, I want a utility thing with that. So, as if resources are there as and when you require, trying to do that. If you look at distributed computing from the like cluster and other type of computing, they also some sort of try to provide some utility based on the user need, and try to, I should not say disconnect, try to basically make the end user less bothered about the nitty-gritty of maintaining the whole resources, right. So, utility computing, if you look at it, is a purely a concept which cloud computing practically implements, what we will see later on. It is a service provisioning model, right, in which a service provider makes computing resources and infrastructure management available to the customer as needed and charges them for specific uses rather than the flat rate, right. So, the word utility is used to make an analogy to other services like electrical power, right, that seek to meet fluctuating customer needs, charge the resources based on the uses rather than the flat rate basis, and this approach sometimes called pay per use or what we say pay as you go model. So, if we look at our electrical services, electrical things, so we have a meter. So, and we whenever I switch on any electrical appliances, it may be power, it can be my electrical light or microwave oven or air conditioning or computing or computer, whatever I resource. So, as much as I consume, that much I pay based on the rates etcetera, what is decided by the electrical that electric authority or electric power authority and type of things. Now, I really do not care or do not know how these powers are generated, how these are coming to up to my home. Only what I care that I have a metered service, right. Whatever I use, it is a service which is metered. Another popular usage is our telecom services, especially the mobile services, right. So, that also we use as a utility. We take a connection from again a telephone or mobile service provider, and then I pay as I use, right. It may be postpaid, prepaid and type of things, and based on that whatever the model of payment model. But I do not care that whether the service provider 1, mobile service provider 1 whom I am using another mobile service provider to connect me to somebody else etcetera, etcetera. What I need that facility like calling, sending messages and maybe data services, right, data video services on the things, and I am ready to pay the things, right. So, based on that I select the services. So, this is also utility services. So, this typically it is metered and pay as you go model or pay as you use model type of things. So, this is a paradigm shift or how we are looking at the computing, though it is suddenly definitely suddenly one day utility computing or cloud computing come knocking at the door. So, it evolved from these all distributed systems to computing to cluster to type of other things, right. So, there is a nice picture, a nice analogy like as if there are different IT resources, and if I open up the tap, I can have these applications, resources falling from the tap. When I do not require, I close it. So, utility computing has a usually so what we view as some form of virtualization. so that the amount of storage or computing power available is considerably larger than a single system sharing computer. So, what we are thinking, it is a enormous amount of resources are there, which I can use as I go. It can be unlimited computing thing which is there, it is unlimited networking, unlimited applications which is there. Like think about, if we try to make an analogy, when we using power, right, unless there is a restriction by the things that you cannot use more than so much kilowatt or so much megawatt, that is a one thing. Otherwise, what virtually you are thinking, that there is a enormous resources available at the other end, somewhere or other, and I can tap anything which I want to use and I pay for the thing, and I do not want to use, I close the thing. Similarly, for the computing also, or even if for telecom or mobile services, what we say, whenever I am downloading a particular say file, I say that the bandwidth is something which is available whatever I need, right. It may be 10 KB or 100 KB file, or it may be a 100 MB file, right. So, but the resources are there, I need to pay for it, I need to pay for the whole thing, but I am able to use it. So, that is another way of looking at it. So, in case of utility computing, what we are trying to see, that the computing itself, starting from infrastructure computing resource, maybe that is hardware, or the services like maybe a particular platform where we compile etc., or maybe that some particular data storage capability, I can store any type of data, or it can be some software, like I want to run particular simulation or mathematical simulation tool, and I say that whatever extent I want to use, I can use it, I need to pay on it. So, it is as if a huge enormous storage of things which are there in the thing. So, it has typical pricing model like our power grid, pay for use pricing model. So, that is the major, one of the major thing. There is another aspects of data center virtualization or provisioning, right, that we will come to that. That means, I virtualize the resource at my end. Say I want to emulate a particular system which has, I want say a particular processor speed so much, 8 GB, 16 GB or 128 GB RAM, so much hard disk, and I want to run a particular scientific simulation for my purpose, right. So, from the whole volume of resource, I virtualize the resource for my, or customize the resource, which is as if as a virtual instance. Another user from the same pool of resources may be virtualized for some other things, right. So, it is a, if we say that the whole thing as the data center virtualization and provisioning solves resource utilization problem, right. I may having lot of resource at my thing, and this allows me to basically supplement these resources. I can outsource some of my thing, like say whenever I am doing this, I am outsourcing say software maintenance to something else, or data storage things to something else. So, I can do outsourcing. Web service level delivery, like, so that we will see, that is what we these days what we are, or rather last couple of means rather last one decade more primarily, we have shifted from a data driven architecture to a service driven architecture. So, what we look at more as a services than the data, right. So, that is it utilization, and then I have a enormous scope of automation, right. If I have different resources etc., then the whole I can have I can build a workflow which allows me to automate the whole resources. So, that is another aspects of this utility computing. So, one example may be on demand cyber infrastructure, like I want to do a particular say examination for recruiting some or recruiting or take test of my students, and I want to have a separate infrastructure, and they maybe are in different physical location, maybe in different departments, or if they invent from their halls. I want a cyber infrastructure which allows me to have a virtual resources which they can take their exam, right. So, this I can have this type of cyber infrastructure. I can have a typical cyber infrastructure in case of a say some event management, typical event management, like I want to manage a conference, and for that period I want to have service cyber infrastructure. I can have a infrastructure for disasters management, which is more of a real time. Their resource need may vary from one to another, but I do not want to keep those resources. Like I say here at IIT Kharagpur we organize conferences, it may be coming in a 1 or 2 in a month or type of things, workshop, etc. And I do not want to keep a separate infrastructure for the things. I want to make a infrastructure as when I require, and I may pay for the things. So, that is one on demand cyber infrastructure may be the one thing. There is another aspects of things whenever. So, what we see, there is a provider or service provider, there is a consumer. Those two category of things has different requirement, and we have different models or different what we say management issues which ties them together. Like one may be pricing, what price you give, right. So, that say I want to, if we take again an analogy, I want to take a service provider which gives me a favorable price for my services, like I want more of a data service than calling, I want data services more. So, I want to invest on those, I want to select those service provider, mobile service provider who gives me a better rate or better performance. I do not care about the rate, but performance on these data services. Somebody may be more interested in the calling or messaging. So, they will do on their own. So, that is the pricing model. There should be a service level agreement, like if I do this type of things, what should be the service level agreement, what should be the availability, downtime, etc. There can be a security aspects, right. If I say I want to use and store data, etc. So, somebody else should not be using or looking at my data. So, there is a security aspect, even security aspects like denial of services type of things should not be there, that also I can look at the security aspects. There can be access mechanisms, etc. And there may be a need for application sizing. The application need to be sized for me. Some application may be for doing data churning for terabytes of data, but I do want to analyze with some megabytes of data. So, I do not want that large application, neither I want to purchase the thing, but I want to size the application based on my need, right, or in like reverse in the other way. So, there can be different type of payment models, right. So, it can be flat rate, tiered and type of things. Different pricing model for different customer based on factors like scale, commitment, payment frequencies, etc. I can have customized things. Principle of utility computing remains same. The pricing model is simply an expression of the providers of the cost. That means, it is a how much provisioning of resources, etc. will come into that. There are several risks we say or disadvantages based on this utility computing world. One may be the data backup. My data is somewhere, if there is a crash, what will happen, right. You store the data in third party, and if there is a crash or that service provider itself goes out of the business, then what will happen. There is a data security aspect, somebody else is reading or my data or not. There is a competence issue, that what I am working with, whether that organization is competent enough. Defining is SLA is another big problem, because everybody want to define that agreements on their favor, and there is still not very standard approach of doing that across the different provider and consumer. Getting value from chargeback, that is also things which we look at, that how I get values of my chargebacks, and these all will evolve as a cloud computing, right. So, cloud computing is a model for enabling ubiquitous, convenient, on demand network access to a shared pool of resources or configurable resources such as network, server, storage, application services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So, it says everything, right. So, this is the typical NIST definition which we all everybody try to what we say follow or respect. So, it says that a huge pool of resources can be provisioned with minimal management effort, and provision and deprovision when I use it and when I want to release it, both can be done in a very seamless manner. So, this if you look at what we have discussed or from your background computing knowledge, This is something which is not came up suddenly on the table. What it there? It evolved from some of the things. Like rather we want to look the computing world in a different way and try to facilitate computing to different type of purposes with some basic modeling, basic model like pricing model, SLA model, say there is a security model, management things. That means we want to place different things, and so that a computing as a service can be provided. Right? I want to provide computing as a service. So, what we will do with this, we will end our today's talk, and we will continue with this thing with the different other aspects of the things. So, this we will do. Another aspect I want to mention that some of these materials, some of these figures etc., are taken from different resources. I have tried to put all the references and acknowledge those things. We want to do it specifically for academic purpose only, for that, for our learning mechanisms, nowhere anything commercial is involved. So, what we do, with this we end our today's talk, and in the coming lectures we will look at other aspects or different aspects, not other aspects, different aspects of cloud computing, how it grows and what are the different aspects, what are the different properties, advantages, disadvantages and like that. Thank you.